Hey class, this is like a reboot of number 78B because on the problem set I made a mistake and I want to make sure you guys get the right information. So take a look at this for 78B. Now by this time we've already done 78A where we draw the Lewis structure for the PF4Cl molecule. You'll notice that for the Lewis structure, P is the central atom and the central atom is attached to chlorine. Chlorine is less electronegative than fluorine. It's a 3.0 as compared to fluorine is 4.0. So the question in 7b that I want to get to make it obvious, like which would you expect to produce a larger electron domain, a PF bond or a PCl bond, okay? Now if we take a look, the PF bond is going to have a difference. I think P is 2.1. And obviously F is 4.0. So that's going to be the 2.1 or 4.0. I forget which one it is. For there. That's what I'm looking for here. Okay. So I got my paper. 2.1 for phosphorus. 4.0 gives me a 1.9. That's a really polar bond, almost ionic. But 2.1 for Cl and 3.0 for, 2.1 for phosphorus, 3.0 for Cl. Now that's a 0.9. So that's still polar, but not nearly as much so. Fluorine pulls really hard on the electrons. So each of these fluorine molecules, like each of these fluorine atoms are going to pull, as you see up here. Let me circle up here so you can see what's going on. Like this one, the two electrons are up close to where fluorine is, away from phosphorus, which means that those bonds take up less room around phosphorus because the electrons are further away from phosphorus. That means that the PCl bond, let me just show you, the P and then the Cl bond here, these electrons are going to be closer to the middle, like that. So that means that the PCl bond is going to take up more room than the PF bond will. If you need further explanation of that, think about if we had phosphorus with a lone pair, like what if I had, instead of PF4Cl, what if I had PF3, like this? What happens with the lone pair there, according to the geometry of it, is that the lone pair, the electrons are closer to phosphorus, which is why they take up more room and squeeze these angles in more. That's why the lone pair makes a difference. This is a similar situation where the electrons in between the Cl and the phosphorus atom are closer to the phosphorus atom, which is why this one is the one that produces a larger electron domain, and that's why having this bond and not all fluorine, like PF bonds, would make this a little distorted, which we get into the next question. All right, that's good for now.